Yeah, it is. I know that it picks up. It just showed you it picks up. I changed the
Where are you guys from?
Yeah, or Bowling Green.
I don't actually know the rules of the competition.
It's actually like an invisible dog fence.
Oh, okay.
Wire underneath, and you have little conductors that pick up, the same way as a collar would. It'll pick the fence, kind of let you know how close you are. Because you're not supposed to touch this, or you're getting points deducted.
So what's the goal there?
The goal, if you got to separate each kind. You got a plastic and a glass bottle in the can. You're supposed to separate each one by picking it up and telling which kind it is, and then separating it out. And then if you get, I think, another glass bottle, if you get it in the right spot, it's like 30 points.
So you're trying to put it in the corners or something?
Yeah, see the loops on the three sides, three bags inside of that, and you'll drop it in the bag.
Oh, that's not here right now.
Yeah, back to the seal.
Oh, okay.
So you'll drop it right there in the little bag inside of that.
Is it just one robot at a time? You compete? Oh, they've got some bags.
Yes.
So what do you power yours by? What's the brain?
The big. Oh, what kind of? Use the basic stamp processor.
They still have that program the same though.
How do you detect the different types?
The claw, depending on how far it grips in, because each different kind of bottle or can is a different diameter.
Jess is asleep.
So it's kind of how far it grips in, and it'll know which one's which.
So you don't ever crush it?
I'm sure he wants to see it.
No, well you can see those cans get crushed a little bit. But not too bad.
And so the bar would squeeze together, and when both touch sensors were depressed on both sides, it would stop the motor. It would then, the optical encoder will count how many ticks that it's actually counted.
So you're measuring the length of the bottle?
The length of the bottle, since all the bottles were different lengths.
Oh, cool.
The closest bottles was the glass bottle and the plastic bottle, and even then they were 1.2 inches apart. So even with both of them going in, it was more than a half an inch apart in difference. And,
is that like a drawer slide?
Yeah, that's it. Just move at the same, move at the exact same speed.
Is this like it's like a homemade rack and pinion kind of? It's pretty neat. Oh, just with Vex motors.
Yeah, a lot of the stuff came from Vex because like one of the big things is like the weird thing with the Vex motors, all the shafts are square, and so they're not round. And so like even like all the Vex like optical encoders, it's a square shaft. It takes a square shaft as well. The drivetrains that we're using are Vex, and of course they take a square drive shaft. So they just went ahead and got Vex motors and servos.
That's pretty nice. I mean, that's a lot more convenient than having to deal with set screws that come out and that kind of stuff.
In our position, it's up, and so nothing falls back.
I get it.
So then when you dropped it, or the cam would go back there.
What school are you guys from?
University of Kentucky.
If you got a second, can you explain how yours works? Tell us the different cans apart?
Sure, absolutely. So it has two arms, swoops them back to this lift right here. Now on the lift, we have a force-sensitive resistor.
How do the cans get in there?
Our two arms, we have two IRs.
Oh, is there a hole on the other side?
There is. Takes them and sweeps them in.
Okay.
Puts them right back there. It's a force-sensitive resistor, so we determine how much it weighs. Unfortunately, the aluminum is very lightweight, so sometimes it's hard to determine if anything's really there. So we also have an IR looking at it. So we say, well, if you think you have something there, and the IR says you have something there, but the force-sensitive resistor shows nothing, you must have a can.
Yeah.
So that also acts as redundancy for us.
What was that, a spec?
We misunderstood the size constraints. We were in by 12 by 12 by 18, however, we didn't see that the footprint had to be 12 by 12. So we had a 12 by 18 footprint, yeah. So we had to switch completely from tracks to wheels.
Oh, you had to just hack off the whole bottom of your robot through the night.
Through the night.
Nice. So what's the electronics that you're using?
We're using a microchip PIC processor, PIC 24, so an 18-bit, 16-bit processor. We use those 2 extra bits to the fullest.
Well, the boards are custom. The wheels and motors we're using for that are actually VEX, which goes along with the tracks we were using. So
A lot of people are using VEX stuff here.
absolutely, but we decided our frame wasn't going to be based off the VEX framework. So I had to go with aluminum, cut our own holes. More stability, a little more lightweight.
Thanks for the tour.
Not a problem, man. Have a good day.
The can is actually a little too short for the gripper, so it fits completely within it. And so it's looking for ground or something.
Sure to see if
in the
there's
back,
something.
we got a micro switch that's very, 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 very sensitive. And so we keep the gripper open, and if something touches it, close it. What do you think it is? Throw it in a bag.
Oh, that's neat. So this is like plastic and glass or vice versa. This whole thing flips up.
The arm pulls the item up, and the bag moves back and forth.
Oh, that's pretty cool.
So it can stay consistent. Yeah, I think these are picks.
Okay.
I think it's very energy efficient. We can run it for about an hour and a half before it goes dead.
Wow.
Compared to a lot of these other guys that they
I
run
don't
it for
see a
3
big
minutes
battery
at
either.
times. It's got 2 batteries, one for the microcontrollers and the servos, and one for the motors. And the motor one rarely dies.
Is this? Do you talk to everything through USB?
Yeah, we've got these are USB to FTDI cables, which is essentially USB to serial.
Right.
What they
You have all these different brains, and they all talk just through serial through the USB.
Yeah, the motherboard, the control code works by letting these guys do their own thing, measure at a time, and then it asks it for what it's currently reading.
Where are you guys from? Auburn?
Yep, Auburn University, Auburn, Alabama.
Thanks for the tour.
Okay, we got these are ping sensors. So they send out basically sonar. And that's how we steer to the object. Once we get to a certain point, if it's crooked, it'll try to straighten up a little bit.
Yeah.
Then it'll bring it the rest of the way in. This will come down. Press it there. It gives it about a 2-second delay. And then these fire. We get some values, figure it out.
Oh, those are your size measurements.
Yes.
Is that just like an IR type?
Yes, that's an IR sensor. And
This one?
yeah, so we can do glass. We'll put glass in here, and then since there's more cans than plastic bottles, we default to cans.
Oh, okay. Yeah. Is this a measuring tape for your cable guide?
Yes.
That's genius. Oh, and then what's this? The spool up here.
That was thread.
Oh, that's what lifts it up.
That was the thread.
Oh, and here are your
thread.
pulleys.
The spool is the pulley for the. And these are curtain rods.
Oh, that's your slide.
Yeah.
Where are you guys from? Or what school?
Mississippi State Technical Community College.
Wow, did you see that flip open, Thomas? Now you know why they're having a problem with it.
It has eyes.
Well, yeah, they've got a... And now it doesn't recognize it as plastic.